Today we will discussion on hydroponics farming, their essential factor for developing and how to operate it. So we will learn by. So first we will one sec. First what is the hydroponics? So hydroponics is a Latin word. It's divided by two words. Hydro means water, ponus means labor. It means working with water. It's simply said, it is the art of growing plant without soil. Any plants we can grow it through hydroponic system with a plant what with it need, when it need, and how much amount they need. We know then there's plants physiology, then without physical genetically change, we can possible to grow into hydroponically. So why we do the hydroponics farm? We are already do the traditional farming. We achieve the more and more yield after the green revolution. So why we need to a hydroponics farm? So the difference between hydroponics farm and we do the traditional farming or soil based farming. So we will discussion in fertilizer uses. We use in traditional farming the fertilizer are losses through the various way like percolate, then evaporation, and also the utilized by the weed. But in case of hydroponics farming, fertilizer directly applied through the root zones. So we here fertilizer is very efficiently used. When also same in water uses. Water uses in traditional farming, water are lost through the percolation, evaporation, and translocation through the weed. But in case of hydroponics farming, 90% water we are saving as compared to the traditional farming. Also in when we growing a traditional farming or soil based farming, we need a fertile soil as well as we need a good category of soil. But in hydroponics we can grow anywhere, at a desert, then underground, basement, then a terrace. We can grow anywhere. We do the hydroponics farming. In course of growth and yield, we achieve the 30% more growth than the traditional farming and 25% more yield than the soil based or traditional farming. Also a sustainability, when we use in soil farming, then turn and turn by when you grow same crops year, then yield should be reduced. But in case of hydroponics farming, it is very efficiently. We can use single crop monocropping, even though yield should be not decreasing in hydroponics farming. Then also in the world, every year 83 million people are ill. By end of 2050, total population of world is 9.8 billion people. So we need a more than 70% food production as compared to now. So we need to fulfill the feed for 9.8 billion people. So we need at least 593 million hectare in 2050. So we will convert this much land into the agriculture land. So we can meet the food for 9.8 billion people. Its land is not too, it's not a less land. It is a almost double size of current Indian area. So it is a very hard to convert this much amount of land to in a agriculture land. Even though we have a less resources like 3% water, fresh water available, only 0.5% available of fresh water in the earth. So we can use is a agriculture purpose and other purposes. Also, nowadays climate change is a big issue. In 2020, one estimated 124 million people are hunger due to uneven flooded, irrigation, and droughted and high temperature. So this much regions we converted our next generation or next farming is a hydroponics farming. Also, a commercial hydroponics are growing day by day. Global hydroponics industry has been grown 4 to 5 fold in last 10 years. And global hydroponics market, current market is 9.5 billion in 2020, and next 2028, 22.2 billion US dollar. It is too much amount. Also in India, according to CGR, compound annual growth rate forecasting is 13.53% in 2027. It is a good indication for growing a commercial hydroponics or day by day. Also, these are the advantage for the commercial hydroponics. We are good revenue generation. Also, large rain not required. Then we use the reusable water. 90% water we have saved in hydroponics farming, where area where less water availability, then they use the reusable water and hydroponics farmings like UAE, then Abu Dhabi. They are also growing crops through the hydroponics farming. Also, we control and saving and efficiently use of nutrient, easy pest control, then easy to harvesting. Also, we can grow on off-season crops. So these are the important for the we are converted into the hydroponics farming. But we developed a hydroponic farming before we know what are the important factor for developing a hydroponics farming. So we learn one by one. First, structure, then which type of hydroponic system are we installed, then what are the environment requirement after developing and before, then also which type of nutrient solution we apply, what is C, what pH, then growing media, which type of growing media use, we are learned step by step. For structure, generally two type of hydroponic system or structure required for a hydroponics farming. One is an outdoor project where the natural light are available. Is called as an outdoor project. This project are developed through in agricultural land, NA land, as well as GIDC plot, terrace, or any other open plot. In this project, we developed a different kind of structure like fan and pair polyhouse structure, then NVPH, insect-proof net house, then rain-protected net house, then wire rope net house. Different type of structure here we are developed and do the hydroponics farming. But in case of indoor farming, where natural source of light not available, we provide it through artificial light. Their project is known as an indoor project. Is also this project set up on the balcony, room, warehouse, and underground rooms. So different type of hydroponics system, which crop you are growing, planning to grow into the hydroponics, and which system are preferable, you select, then develop, and then after you can easily convert it into commercial hydroponics farming. So these are the different system we learn step by step. This first is a wick system. Its system in this system, one reservoir, and in reservoir one wick are available. They transfer the nutrient and water through the capillary movement to growing media. Nowadays, it's already, this principle are already used in the safe self-watering pot is available into the indoor farming, or indoor pot, or indoor decorative plant is nowly available into the market. This is a very good initial or beginner for the system, but it not be a viable for the commercial cultivation. Second is ebb and flow system, or also known as a floor and drain system. In this system, the irrigation with water with nutrient solution are passed onto the growing tray with certain amount of fill. Then after drain, it excess nutrient solution through the outer portion. So it's called as a floor. First we do the floor, then after excess water are drain out. So it's also known as a floor and drain out system. In this system, is which crops are more water craving crops. It's best growing in this system. It's easy to build up system. But here some problem in this system, like we use the gravel, pebble, and higher porosity media. So when the power failure, at that time plants should be die. But we can use a small or more water retaining media like rock wool, vermiculite, cocoa fiber. At that time, the water holding capacity are more this media, and water logging problem are issues. That's why root damage are more in this system. So media selection for this system is very actively and most important for this system. Another one is deep water culture, is also known as a DWC culture. Everyone knows this system, or you can see also in YouTube. A foreign country is most viable. It's also commercially viable crops, but larger, not a larger plant. It is a small plants. It's more suitable. In this system, one reservoir, styrofoam seed are floating. In seed, we hold it and put a net pot and we grow the plant. So continuously the root are deep into the nutritional water. Also here one air stone pump. So what they do, they're doing a bubbling into the plant. You can see into the aquaculture. So what is they given the oxygenated solution. So root are perfectly fill up with the oxygen, or then fulfill their need through oxygen. Another one is the nutrient filling techniques. This is the highly commercially viable techniques, is also known as the nutrient film techniques or NFT techniques. In this system, one gully or channel available. In one side, the nutrient solution with water are added into the one side, and another side the nutrient are returned. It's also known as active or circulated hydroponic system. This system is generally commercially viable. In Indian condition, every almost hydroponics farm are developed through the NFT system. In this system, we not require too much media, also less maintenance, also vertical farming are possible through the NFT system. In system, two type of system. It is a flat NFT system, and then one is a A-frame vertical NFT system. Another one is drip system. Everyone knows what is the drip system. The channel of tubes, then divided by the drip lines and dropped to the root zone. So it is a drip system. In this drip system, we are developing a different type of system, like Dutch bucket system. In this system, we one bucket. In bucket, we can grow 1 or 2 plants. Then here, one drip are put a nutrient solution through the dripper, and excess water are returning through the return line and collect from the reservoir. So it is a circulated nutrient solution system. These are the very useful when the water solution or water are availability is less. At that time, we can grow a larger plant like vine crops, like cherry tomato, bell pepper. This is system are more viability in this Dutch bucket system. These are the Dutch bucket system, and we are already planted a bell pepper, yellow and red bell pepper. These are the growing bag system, similar to a Dutch bucket system, but here we cannot be a collect return water. This is the trough system. When we use a closing spacing crops, at that time we can use this trough systems. Also cocoa pit grow slab. Nowadays, this system are more popular than other medias. In this system, readily available growing media, a mixture of cocoa chips, cocoa peat, and here's a dry form. So when we grow, then spread the grow slab and apply the nutrition solution, put the seeds, and you can ready for the growing media. So nowadays it's a more preferable and use into the commercially vine crops and crops for growing. Not hydroponics, but it is a similar concept is aeroponic system. In this system, the plant root are hanging into the air, and we are apply the nutrient water through the mist of nozzles. So water need water or also a nutrient through this misting water. We collect and they grow. This is the commercially mini tuber of potato. When we produce at that time, aeroponics are more usable. Similar aquaponics, everyone knows. The aquaculture are growing similarly and vice versa. We are growing a plant in this system. the fish output or fish byproduct are used as a nutrient for the planting. But in this system, disadvantage is the not balancing nutrient required for the plants. So sometimes plants show the different types of deficiency. This is the hydroponics fodder. It is a very good for the dairy farming, which are growing a dairy farm into the urban area. And this system, you can apply the everyday green fodder for their kettles and goats and everything. So it is a very good system for the dairy farming. Then another one concept is microgreens. Nowadays, most important and most viable, I think, say small woman in growing, they grow the microgreens. Then it is easily earned for too much money. In microgreens is 70 times more nutrition, vitamins, minerals, and polyphenols in this microgreens. So it is a very use for the children, consuming for the children. Also is also known as a superfood. And I am going to a Maldives when agronomy services. At that time, I also growing a different type of microgreens. Also, edible flower nowadays more demandable edible flower. It's too much price. Arounding 250 rupees in given a 10 to 20 grams of edible flower. These are the different edible flower. Another one important factor is environment. One is a temperature. So temperature are more important for the growth and development. Also is depend for the germination, growth and development. Generally, in polyhouse structure, we are maintaining 70 to 27 Celsius of temperature. And through different two type of system, like we maintaining atmospheric temperature or air temperature, we also maintaining nutrient solution temperature or root zone temperature. So we maintain the air temperature. Air temperature are very influenced through for the plant process like photosynthesis, transpiration, then germination and flowering. Also, this temperature are detected from the thermocouple sensors, and these thermocouple sensor are installed between the center of the greenhouse, and we maintain the air temperature or atmospheric temperature with the three system like fan and pair system, then fogging system, and central boiling heating system. Fan and pair system, it is a very well known cooling temperature, is also known as a forced ventilator system. In this system, two principles are work. First is a negative pressure principle, and one is a positive principle. In this negative principle, one side pad are installed. He always be wet with the water. So what happened? The exhaust fan are pass on the hot air into the polyhouse. They pass on the outside. So we develop a spacing of into the polyhouse. So the hot air coming from the cooling pad and into the enter the polyhouse is known as a cooling air. So maintain the temperature, and reverse process is known as a positive pressure system. These are the basic fan and pad polyhouse structure. The fogger are also maintain the relative humidity as well as temperature. When the droplet of the fogger size is decreasing, then increasing the cooling. But we cannot be a fogging start at least 2 or 3 minutes. We are less 10 to 10 seconds are on of fogger. We not be running more time, because we running more time, then canopy are suffering from the highly humidity and develop a different type of fungus and different type of issues we are discussing further. Central boiler and heating system. In this system are generally used into the European countries, and this system in use glass house structure. In glass house, we survey in surrounding the system of pipeline. In this pipeline, we pass on the stream or hot water. So the temperature should be increasing into the glass house. So these are basically used for the increasing the temperature into the European country. But Indian condition, this system are not used. Another one, we temperature maintain into the water solution or nutrient solution or root zone temperature. In soil based, when we talk soil based farming, at that time we are not maintaining the temperature because soil is act as a buffer. But here we apply the nutrient or water is our basic media for growing. So maintain the temperature of nutrient solution is very important. We maintain the temperature nutrient solution through the chiller. We maintain 20 to 30 Celsius degree. In this temperature, above when increasing temperature, then dissolved oxygen level should be down. So it's down, then increasing the fungal attack and root rot attack. These are the two different machines. One is a nutrient solution chiller, is basically industrial chiller. Then one is a nutrient solution heater. It is basically heater. So what happened is an inlet. So we nutrient solution and inlet, then chill out and outcome, and this chilling nutrient are passed on to the NFT or any other media. In also one another factor is relative humidity. Everyone know what is a humidity? Quantity of water present into the air is known as a humidity. Or we have in hydroponics we consider as a relative humidity. The amount of water vapor present into the air compared to maximum water vapor air can be held at the particular temperature is known as a relative humidity. And all the plants, maybe all the plants are growth between this given the range, it's 50 to 80%. In this range, the almost all plants are growing best into this range. Above the 80 Celsius, 80%, increasing the relative humidity, then different type of problem we are facing. Wahan pe, we close the stomatal closure. So what happened? Stomata are closed, then transpiration should be reduced. Transpiration not happen. So what happened? The heat generate to the plants. And also transpiration not happen, then at that time translocation are not in. And translocation not happen, so nutrient and media and nutrient solution are not translocation from root to tip portion. So it not coming a nutrient on nutrient solution into the plant is not translocation. So plants show the deficiency of calcium or different type of boron, and so this type of deficiency are there. Also higher humidity at the time, more spore germination, then more multiplication of diseases and more pests are coming. Also pollen are not dispersible and yield should be reduced. Very low humidity at the time, higher level of transpiration, then plant are lose their turgidity. So how can reduce relative humidity? We are already discussing increasing relative humidity through the fogger, but how to reduce? The reducing through the exhaust fan. The exhaust fan are throw out the moisturized air from outside the greenhouse. Also, one another fan is air circulated fan, is ACF or horizontal air circulated fan. This fan are what to do? The what they moisturizer or moisture are not cover up from the plant canopy. So plant canopy are dry, and into the poly house has been a dry climate maintained. So uniform climate or microclimate maintained through the air circulated fan. Another one is light. Light also important for the basic or most basic metabolism process. It's known as a photosynthesis. So light is important for the everybody for the growing plants. It depend on light intensity, duration, and quality. The light intensity are manufacturing the food strength and color and flowering is influenced, but we are not given a light more than 16 hours per day. So we will, when we grow the indoor plant at that time we notice this hour, and also maintain the light hours. Also, lighting are not more than 80,000 lux, so we will achieve the more yield. When we talk outdoor, so how when we are controlling outdoor lighting through a shade net, we are using generally 50% aluminum shade net, so we will maintain the nutrient lighting. Then indoor farming, we use the HID, high intensity discharge, then LED. Nowadays, most commercial hydroponics farm are use LED because it is a less maintenance, then not generate the heat, so plant are easily growing in this air. Also nowadays in market are specific wavelength LED light available. Also we will maintain the LED light through specific wavelength. The nutrient solution, when we talk the soil based farming, the soil is our soil testing and soil fertility is very important, but we will talk into the hydroponics farming. So water is our basic media, so water testing are more required. When we start the project, at the time we testing the our water, otherwise water are not good, so we use the RO water, because RO water, in RO water no anion and cation, so we will need which type of nutrient we will make it through a RO water. These are the different essential plant nutrient we will balance. In hydroponics farming, two factor keep in your mind when we work for the nutrient. The core of hydroponics farming is nutrient solution. Here we are not a soil. When we talking about the soil, we apply the urea 2 times in the cycle, we apply the DAP in single time. So what happens, DAP or urea is stored through the soil, and when the plants need, they suck it. But here we are not use any kind of storage material, we are directly dealing with the water. So balance nutrient with a particular amount with correct ratio, when the plants need, which type of plants and their needs, we all these are factor in our mind and we apply to the this nutrient. These are the nutrient type: part A, part B, and part C, and buffer. We are applying nutrient to the electric conductivity. So what is electric conductivity? It is the ability to solution to carry the electric current. We are knowing to measuring with the electric conductivity or EC, to measuring how many nutrient strength or nutrient are available into the water. So it is a basic parameter to know what kind of or what is the strength of or nutrient into the water. So electric conductivity are more use, and without EC we cannot be apply any kind of nutrient or any kind of fertigation into the hydroponics system. EC is generally measuring to the millisiemens per centimeter. Other items, other any also known as a TDS is also total dissolved salt. It's a convergible factor. 1 EC is equal to 500 TDS. pH also important. In pH, we between 5 to 6.5 are most suitable for every crops. Say easily uptake the nutrient. So we will maintain the also pH between 5 to 6.5. Usually 6 is precisely for better growth and better yield. If pH is above 6.5, so we will decrease with the phosphoric acid 85%, and if pH is lower than 5, then we will increasing with potassium hydroxide. Growing media, it is also important for the supporting of the plants. So their characteristics is chemically stable, it is clean, it is the not create a waterlogging problem, but it is a adequate water holding capacity, also a more air holding capacity, means it is a preferable for aeroporation. It is a required air holding capacity. Otherwise, we issues the root health. Also, a buffering capacity. When we use the pH, sometimes what happens, pH are more sucking through the auto dosing system. So the solution of pH is too much down or too much high. At that time, the media should be act as a buffering capacity. Also, they have a good cation exchange capacity, so easily transfer a nutrient from nutrient solution to the plant. These are the different media are available into the market, which type of system you are used, which crop you are growing. Accordingly, you can use a prefer media. Generally, we are three type of media are used in our farm: Oasis cube, grow slab, hydroton, or cocoa-peat. Location also important, because when we develop the project, first we site feasibility are important, because what happened when we develop the project, but light coming, light electricity are not coming. At the time we facing the issue, then water are logging area, so water also problem to our farm. Also road connectivity are not available, so location are more important into the hydroponics farming. Also, after developing project, we use the weed mat, so unwanted things from soil, weed, and soil-borne diseases are not infect to our plants. These are the different exotic crops we are use or we can grow into the successfully into hydroponics system: Lolorosa, Locano, Romin, Iceberg, Red Oak, Green Oak lettuce, Summer Crispino Magneta, and Butterhead. Different herbs: basil, parsley, thyme, rosemary, spinach, Swiss chard, bok choy, then arugula, oregano. These are different vine crops we can grow easily into the hydroponic system. Different exotic cherry tomatoes also we can grow in. These are the medicinal. Currently, I am work on the medicinal plants into the hydroponic system. We are, I think, a pioneer into the medicinal hydroponics farming. The turmeric, black ginger, and ginger. Different medicinal plant like Brahmi, Ashwagandha, Kalmek, saffron. We also growing our HO saffron to indoor planting. Then Manduk Pani. These are the different exotic vegetables we are commercially grown. Previous company at the time we are growing. Indoor strawberry also we are growing. These are the different wine crops. Kalmek, rosemary, Brahmi. Currently we are growing this medicinal plants. These are the Bhut Jolka. It's also known as the ghost pepper. World hottest chili is known as, we are commercially growing, and we extract the capsaicin content. We got the good 3.5% capsaicin content from Bhut Jolka. Then we also different type of R&D do, like rhizome bud techniques into the turmeric. So we can reducing the turmeric cycle at least 1 month. We single bud system use. So what happened? We need a less amount of rhizome required for the seedlings purpose. Also time less for the growing purpose. Then we are also vertically and horizontally grown turmeric. Different type of turmeric we are growing, different variety. The different pest and nutrient and diseases are nutrient deficiency, pest and disease observed into the hydroponics farming. These are the chart for micronutrient and macronutrient deficiency into the plants. Earlier I say, when the relative humidity too much high, at that time plant not able to translocation of nutrient or water. At the time we show the deficiency is a necrosis. You can see a deep burn is known through the calcium deficiency. Here you can see. Also lacking to the plant, it is an indoor planting. We are not providing the sufficient light, so the plant are lankiness. So it is a not commercially sellable lettuce. So it depends when you follow the proper cultural practices or growing practices. These are the different pests also observed into the protected cultivation. It is like mealybugs, spider mite in spinach, caterpillar in Italian basil, then thrips in capsicum. This is the very economically damaged through the thrips into the capsicum. Also in tomato, whitefly, then aphid into the iceberg, different type of disease. When relative humidity high, that time basil down residue, then Chinospora root rot also observed. These are the different action precaution for the fight against the pest and diseases you can follow for better and healthy crop production. Also for project operation, your selection of staff, labor and caretaker is most important. It is a semi-skilled worker required. Everyday meeting are required. So what kind of germination we can do, what kind of harvesting today, what is the order. So it is a commercial in when we growing a commercial purpose, then it's kind of exercise are most required. Daily activity, like what kind of kgs are harvesting, what kind of seeds today germinated, then packaging are important. Also in hydroponic farming, one good thing is you can forecast the yield. You can suppose you need of after 3 months some kind of xyz kg required lolo rosa, so you plan a reverse process, because here mortality are too less, around 2% our mortality are here. So you can predict the yield and you can forecast the yield. So easy to marketing. Also storage or shelf life, then maintenance part also, and safety of unit. When you develop the project, then surrounding, you borderline are required, or safety of your unit is must required. Thank you so much. Now open for question.